So now that we've already discussed descriptive measures of a quantitative variable, we're going to turn our attention to a sampling distribution. The idea of a sampling distribution is not new to us. We discussed sampling distributions when we had a categorical variable. So we're just going to apply the same ideas, but now discuss how they're different for a quantitative variable. We're going to do this by first understanding through an example. So in this example, we have people that are going to roll one single die, and we're interested in the value of that die, because whatever value they roll, that's how much money they will win. So if they roll a 5, they will get $5. We have a total of 3,000 people roll a die and got the results. So we can see about how many people rolled a 1, rolled a 2, rolled a 3, rolled a 4, rolled a 5, and rolled a 6. In addition, we got some values over here of a mean, a median, and a standard deviation. So we're first going to go through some of the old stuff. So in this example, what is our variable? Well, what we are recording is the amount of money that someone's winning. So that's what I'm writing down. So they rolled a 1, they got $1. Now, how would we summarize the data? So let's go through those same characteristics that we did when we had the PGA players. So looking at the shape of my data, how does it look? Well, this one really is not horribly exciting. This is actually one that we would classify into that uniform. That is relatively flat. There's really not a lot of differences, and that makes pretty good sense here because we sort of would expect the same number of people to roll a 1, a 2, all the way up to 6, if it was a fair die anyway. Are there any outliers? No. Right, we have over 400 people in each of the groups there. That's definitely not an outlier. We have the measures of center of our mean and median over here to be able to interpret, as well as our standard deviation. If you recall, when we're going to interpret standard deviation, I generally do my little number line thing where I start at the mean, which is our 3.543, and go out my standard deviation in either direction. And then since this is money, I end up rounding it to just 2 decimal places. And so we'll be using those numbers in our interpretation here as well. So what would this look like? So then, when looking at how much money was won, by our 3,000 people, first, I'll start with shape. So the data was pretty uniform. With no outliers. Moving on to our center. So I can say the mean amount won. So that was $3.54, rounded to 2 decimals. And with the median, we can say half or 50%, same thing, of people won $4 or more. Finally, with my standard deviation calculation we did over here, I can say that the typical person won between $1.86 and $5.23. Right, so that's not really anything new yet. Something to think about. This was each person rolling one die. So what if instead of rolling just a single die, each person instead rolls 5 dice all at once? For each person, we calculate their mean. So if you rolled all 4s, your mean would be 4. But if you had like a couple 1s and a couple 6s, we would average your values together. And that's how much money you win. So similar setup to above, but instead you roll 5 dice and you're going to get the average value of your 5 dice. What do you think might happen? Would the data look the same? Would the mean stay the same? The median? Standard deviation? Would any of those things change? Why? Why not? How would they change? Let's move on to the next video to find out how.